those of you guys just joining us on the video, the computer broke. But then they started looking at the homework that's due tomorrow and seeing what they already know how to do while I was trying to get the notes up. So you guys were peeking at number 7. How would you do it?
Rewrite.
Rewrite it? How?
1 times 1 over 10 to the minus 1.
Oh, so you can like do a 1/10 and another 1/10 and another 1/10 and another 1/10?
Yes.
Yeah.
That's a little confusing. But wait a minute. Even if you rewrite it, can't you already tell it's going to diverge? Can anyone give me a reason why? Even without rewriting it to say, oh, it's a 1/10 and then it's another 1/10 and then it's another 1/10 and then it's another 1/10.
It's always adding 1.
It's always adding 1 and a little bit more. So what's going to happen when you add 1? 2. When you add 1? 3. When you add 1? 4. What's going to happen as you keep adding 1? It's going to keep getting bigger and bigger and bigger and bigger and bigger. So question, what's the limit as n goes to infinity of the terms?
1.
1 and 1/9, which is not 0. What convergence test says that automatically must diverge? Nth term test. Yeah, so nth term test, we could have said divergence on that real quick. But I guess you could have also done something with the partial sums. That's gross. But then, what's going on in numbers 14 and 19? What's this section saying? They're both geo series. Look and see whether or not the ratio is magnitude less than 1 or magnitude greater than or equal to 1, right? If magnitude less than 1, we find the sum. Okay, so that's pretty much like what we've already done, where we've already been. Remember, our book is covering geo series for the first time, by the way. Because remember, we went and did a timeout and did a whole other book, an extra chapter. What's going on in 21 and 23? I don't remember if I assigned you those. They're crossed out. I don't really know. There's a story somewhere. Find the interval of convergence in the function x represented by the geo series. Who's the common ratio in this one? 2 and x? Oh, yeah, because it's 2x all to the n. Just separated. So wait a minute. How are we supposed to find an interval of convergence if we have 2x?
2x.
Huh. Where did we end yesterday in our notes? When the ratio is something other than x. Ooh, maybe we should take some notes and then we'll go back and see how homework's going to go, yeah? So, here towards the end of yesterday, we were getting to an endeavor card. And part of that endeavor card that I can zoom in on in just 1 second, part of that endeavor card was, ooh, check it, power series, representation of functions, an interval of convergence. R less than 1. Who's R in this one? X squared. And how do we know it was x squared? By the a sub 1 over 1 minus r. Who is in the r spot? X squared is in the r spot. So question, what would be the interval of convergence for this guy? It's not x, it's x squared. If interval of convergence comes from setting the common ratio less than 1, where does this lead me? Does that make sense? Does it make sense to go to negative numbers? Because x squared itself can't go into the negatives, right? Now, can it be 0? Technically, yes. And is 0 less than 1? Yes. But it doesn't make sense to set x squared greater than negative 1, because that would always be true. But how do I solve for x? Yeah. So technically, if x squared is always greater than or equal to 0, we might not even actually need that. Technically, maybe we could just go ahead and solve as is, even though it is greater than or equal to 0. That's true. What happens, though, when we square root of squared? I'm teaching my Algebra 1 kids, but I didn't teach you absolute value of x. Wait a minute. What does that mean? Oh! Okay. Doesn't make sense have x squared be in between 1 and negative 1. We're supposed to be getting x by itself. However, it does make sense to have x alone between 1 and negative 1, although you might have lost that somewhere if you hadn't thought of the absolute value of x. Okay, well, wait a minute. That was boring. Nothing really changed. It's still just between negative 1 and 1. But will it always be that way? Let's see if I have another example close. Oops, that's, I counted out the page. Ooh, how about this one? We'll go back to the endeavor card in a second. We're just talking about interval of convergence. Find a power series that represents. Does it look like Geo? Yes. So we can think about comparing this to my A1 over 1 minus R, right? We'll talk about interval of convergence in just a second. Question, what's my first term? It says right the first 4 non-zero. 1, then what? Plus or minus 2x? Why plus? Yeah, my Geo series is 1 minus R minus a positive 2x. So times 2x, what's my next one? Times 2x, what's my next one? Uh-oh. And the general term, 1, 2, 3, 4, general term. Does that make sense? Because if I start at 1, 1 minus 1 is 0. Goes away, but the 1 is still there. 2 minus 1 is 1. 3 minus 1 is 2, etc., etc. 2 is being raised, and x is being raised. So I've done this. I've done this. I still need that. But what did we just talk about with interval convergence of Geos? Ooh, this is going to be more exciting. Now what? Take time, take time, take time. Does that make sense? Now what am I allowed to do? Could I split it up and do them separately? Yes. But what's going to end up happening to everybody when I split them up and solve them separately? Do you guys see it? So what's x going to be within? So now, can you peek at homework again? So what's going on when it says find the interval of convergence? Aren't we going to be thinking about who's the common ratio and setting it less than 1 and then solving for x? Does that make sense? I remember from yesterday when I had that 1 over x and when I had 1 over 1 minus x and when I had the 1 and 1 plus x and 1 plus x squared and 1 plus x cubed and 1 plus x to the 4th. Remember, it was only converging closer and closer to the curve right in between the interval of convergence. Everywhere else, it's not a good approximation. Well, it's not converging. It's not even about it being a good approximation. It's literally converging to the curve itself, but only on a certain interval for these ones, for Geo series, because they are restricted. I don't want to give away all of homework. What's going on in the next section? Geo series and it has a sign? Okay, I don't know. I think the R might be a sign, but what's going on down here? Everything starts to change. Now what? Do you see how it changed from fine to what? Now all of a sudden they're saying, wait a minute, there's something we can use this to do. Okay, hold on, keep reading. What do the directions say? Use the series. What series? The one we found. And the one we found. Oh, that's why I crossed out, because you needed 21 to do 27. You're welcome. Anyway, use the one we found to do what? To find a power series for f prime of x. Oof, I think we have some more things to learn. But before we learn those things, using power series, let me make sure that you have that forever card, that endeavor card from yesterday. This is actually one I just added last year, but I added it in response to issues that BC kids were having on using Geo series. I'm trying to get it to be a good zoom. Can I get it? Ugh. Oh well, I'm just going to do this. That doesn't help. I made this in response to issues that BC kids were having. On manipulating, using, forming, making power series. So I would just call this the power series card. This is a huge old power series card. Power series cards, or card. If the R is just like X, it'd be X, X squared, X cubed, X to the fourth. But as we've seen, R can be all sorts of different things, and we barely just saw, wait, R can be a sign? So it's not even a polynomial anymore, but it's still a power series. Anything of this form does fit the geo series, or does fit, can be represented, does represent a geo series. Therefore, we can find the sum of it. But remember, this is only the sum over a certain interval of convergence because it's only for limited R's. But then, do you guys see the change in wording? How do we use power series to build other functions? Well, we can do compositions. You guys have been seeing us do that a lot because if something else is in that U spot, we can go ahead and just plug it into that common ratio spot and then simplify. If we have a different initial term, we can start at a different place. If we have the whole thing multiplied by something extra, we can distribute that all along the way. But all of a sudden, now it's also like, wait, but we can also, instead of taking a derivative of this, we can take a derivative of the power series. Or instead of integrating this, ln, where did he come from? We can integrate a power series. So we haven't fully seen why all of this is true or why the heck an ln just showed up unless you're just thinking very critically. Maybe you can figure it out. Huh?
So usually like when you do
ln is 1 over u, right? Times u prime. And so if I'm integrating a 1 over u, wait a minute, 1 over 1 minus x might go back to being. We're in endeavor number 600? No. Ratio root test. Yeah, that was the last one. For some reason I thought we had done another one, but I don't think we have. Because this is 10-1 versus the beginning of power series. And ironically, once again, our book is covering power series before doing anything to do with convergence and divergence. They're just saying geo. Let's go really deep with geo, and let's talk about how geo can be used. In other books, it's like, hey, geo, convergence, divergence, let's move on. What other convergence, divergence can we do? And then they come back to geo. Most of us are the second half of the card. Yeah, can I zoom in? Are all of us down to the can be used? Yeah. All school. We've done compositions, we've kind of done combinations, but derivatives and integrals. P.S. We definitely have some AP packets on this one. We didn't really tons on the last one, because convergence and divergence are mostly multiple choice. But the AP does, once again, love to force your hand and make you understand the full ins and outs of the tests. Hence why I needed you to know them perfectly. And our chapter 10 builds upon them. But a lot more AP-ish questions will be coming based on our work from chapter 10. Once we get through chapter 10, we have covered everything to do with series for CalcBC. Chapter 11 will be, let's go back to parametric and polar, which means a little bit of vector calculus, not a lot. Mostly trying to figure out polar, define functions and how to derive, but more importantly, how to integrate and find area within polar curves. That gets interesting. The vector calculus is the easy stuff. Well, what they give us. So what are they taking the derivative or the integral of? Who is f of u? They're still pretty much just kind of comparing everything to 1 over 1 minus x. And so, or 1 over 1 minus u, or a sub 1 over 1 minus u specifically. You guys can see it defined up here. So when they say the derivative of f of u, the derivative is, well, this is to the negative 1 power, and so therefore the derivative negative 1 power brings down the negative, makes it a negative 2 times u prime. Okay, that's the quotient rule, or the power rule. But if this equals that, we could also take the derivative piece by piece. Derivative of a constant is 0. Derivative of this times u is just that. Times u prime, and put the u prime at the end. Plus, bring down the 2, 2/8. Anyway, taking a derivative piece by piece will lead to simpler pieces, but even more importantly, a power series for this without, well, let's just call without further work. You don't know any other way to make a power series right now, so it doesn't really show you how much work is saved, but it is helpful. And if we're integrating our function, wait a minute, why are they calling it f of x? Why did they just change? I actually don't like it, they just changed, but that's okay. We want to anti-derive the original function, thinking of it as an a1 over 1 minus x. I think it might just be for the dx to make it simpler. And as Kevin was already saying, the integral of 1 over u is ln. However, what's a little awkward with what they showed? Come on, I'm teaching CalcBC u sub right now. They have their test on u sub tomorrow. They could really use some tutoring. What's weird? Come on, mental math is about the u sub that happened. Okay, where did you go? But then they redefined it in terms of x. So it's like, okay, well, what if it's a1 over 1 minus x? But still, what's it? No, the square is going to take a derivative. When you take an integral 1 over u. Yeah, where's the negative? U sub. U is equal to 1 minus, okay, x. But wouldn't du be negative 1? Shouldn't I have a negative? Oh, what's a1? Well, it's not an arbitrary constant. It's the first term. Where did the negative go?
But the integral should be the positive value.
The area can be above or below. I'm not sure that we can say the integral would just be positive. I'm actually asking the question legitimately now. I was totally going to have it like be absorbed into the arbitrary constant. I'm like, wait a minute, a1 isn't arbitrary, a1 is the first term. Where is the negative? Should it be there? Right? Because we would have antiderivative of x minus antiderivative of a. Huh. Can we just put like a little star right now and then stink? Yeah, I don't know why there's not a negative. If there was an arbitrary constant, it'd be fine, but a sub 1 is the first term. It's not like an arbitrary c. I'm going to put a little star by that. And my question is, why is it not a negative? I might disagree with this. I did just bring it in last year, so maybe I kind of was building it myself, but maybe I copy and pasted it wrong, or maybe I think I might even type this one out. I mean, this one has a negative, but that was from the u prime. And we're integrating, I believe, this original function just in terms of x. We'll get back to it. We'll get back to it. Do I want to go straight to derivatives? We're almost to it. We're right about here. I think we'll skip that one, but I still want you guys to do this one. We'll skip the 4 plus x. Let's see sometimes we go figure out that one, or maybe after you guys do homework, check your understanding with that 4 plus x. He's a bit more tricky. But what about this one? What about this one? You guys just wrote a card, right? But wait a minute, where was your power series centered? At 0. What changes, and maybe you might even want to add this to your card, what changes if it's centered somewhere else? You have to shift it. And how do you shift?
Inside of it.
So if I need to have it centered at, instead of 1 minus x, I need 1 minus x minus 1. But wait a minute, can I just randomly put in a number? First of all, what's bad? Why did I put the negative? Because I need my a sub 1 over 1 minus r. My r is going to be the x, but I need it to be minus. I can't just put a negative, can I? Can I put a negative over a negative? Maybe a little too fast for some of you. Let's do a sub 1. We're trying to make it look like this, yeah? What do I have right now? If I want to throw in a negative, I can't just throw in a negative, right? Where else do you need to put it? Okay. So far, so good? Okay. But don't I need a number minus? And if I put in a number, don't I also have to offset it somewhere else? Right? I complete the square. I see the centered at 1, so to be honest, I don't have an option. I need this to shift to the right 1. Hence why I'm putting in x minus 1. But won't that also help me with getting my 1 minus r? So if I put a negative 1 here, what's going to offset it out here? 1. It already is a plus 1. I need a negative. How can you double check?
This is crazy.
Yeah, you can mush it together and make sure it goes back to this, right? So if I distribute, that would be a negative x, that would be a positive 1. The 1s would cancel, the negatives would reduce. Is it the same thing? What did I just do? Expand it to make what I want. So I complete the square, but in a whole more advanced context. Well, what could I do at this point? What's Lainey seeing? She's like, there are negatives everywhere. So what could we do? We could just multiply top and bottom by a negative 1 and say, well, I thought I needed them, but you know what? I can just, and then I can just, but why does he stay? He's in the parentheses, right? So now double check. Okay, wait a minute. So if I distribute, that's a positive, that's a negative, they cancel. Oh, I guess I didn't need a negative after all. Oops. Now hold on. What would my power series be then? Where am I starting? What would the next one be? What's my R? Remember, times R. Times. You see it? I need 4, but I ran out of space. But we would have plus. Oh, I didn't write my minus and negative. Thank you. Bummer. But what's that going to change?
Just the same.
And it's not going to be every sign, isn't it? Just going to be every other sign? So aren't I going to have a plus and then times a negative and then times a negative because my R is equal to negative x minus 1? So then when I get to my general term, though, what else do I need? But hold on, does it start negative or start positive? Starts positive. Would n minus 1, yeah, 1 minus 1 would be 0, and then all of a sudden 2 minus 1 would be a negative, and then 3 minus 1 would be a positive. Okay, there we go.
What represents in this scenario?
What would the
So what represents? Inside a power series that represents one of them.
represents? This is going back to our general idea of power series and how a power series converges to a rational function. So our rational function can be represented by a power series. So I can say that 1 over 1 minus x, or sorry, 1 over a sub 1 over 1 minus r is equal to this power series. This is function notation, and this is power series notation. So we can say that a function can be represented by its power series. Well, one that can be seen as a geometric series for right now are the only ones we know how to do. But if I can take a function, if I can represent it or compare it to a geoseries, then I can represent it as a power series. But only
So what we do is,
only working for a certain interval of convergence.
and so what we just did is just setting 1 over x equals to a1 over 1 minus 1. So that's the thing we are looking for.
We rearranged / transformed 1 over x into a geoseries form so that we could represent it as a power series. Because we didn't change the value of 1 over 1 minus x, right? We just transformed, like a t-proof. We didn't change what like a trig expression was, we just changed what it looked like. Or like a trig form of a complex number, or like trig substitution, totally changing a function to be in its trigonometric form. In terms of theta, we're taking a function and putting it into its power series form. So that's like where that representation is coming from.
So the first
Function series.
So first fourth term is just like if you don't, not given, we're just using.
I ran out of space. Sorry. Should have gone.
Yeah, but we're just using x if no number was given.
Right. And they could give us a number, then we would plug it. But hold on, what haven't we done yet? So how do I find my interval of convergence if I know my common ratio? Yeah, so then take it, right? Set the absolute value of, wait a minute, what does an absolute value do if I have a negative? Makes that positive. Does it make that positive too? But a negative number with an absolute value changes into a positive, right? Or an opposite, I should. So that negative 1 can turn into a positive. So I have x minus 1 being in between negative 1 and 1. So then if I add to both sides, because I could split it apart and do it separately, but if I add, I would be adding the 1 to both, so what did I get? There we go. We were doing a couple things in this problem. We were trying to find the power series representation, aka we were trying to see this in terms of a geoseries, so we could make that and determine for what interval it's good. Mm-hmm. And so if I was to, I'm going to answer Lorenzo's question as I pull up my calculator. If I was to take this and throw it in my calculator, what should this be doing? Getting closer and closer to my function 1 over x, but not in between 1 and negative 1 like we saw yesterday, but in between 0 and 2 instead. Lorenzo, what's up, bud? Oh, Kevin.
So for the interval of convergence, does it like matter the notation? So like, could you do like x within 0 to 2?
Oh yeah, sorry. I'm just showing the inequalities because I think for solving purposes, absolute value, seeing it's between 1 and negative 1, gives you like a way to solve, as opposed to interval notation. It would be confusing.
It doesn't matter like.
As far as the final answer, no. No, you could do parentheses. So sadly, I totally had to use the calculator for honors pre-cal today. There we go. And don't worry, we're going straight next to the derivatives and integrals, which is where homework goes next. But I'm just trying to show you once again the idea of here's my 1 over x, and then Lorenzo, this is the function notation, and this works for all real numbers of x, right? 1 over x for all real numbers of x. But if I start putting in my, well, 1, that's not that great, but then I could do my, there we go, and I could do, I don't remember what my calculator or my computer does or doesn't do. There we go. Nope, it doesn't like that. Ah! Sometimes I wish I could just type it. It'd be so much nicer. Minus x minus 1. And then I could do my plus x minus 1 squared. This is shifting that whole convergence that we had yesterday over to a new interval. And it's also for a new function, like it's centered around a new spot. We were able to rewrite it in a different location, which is part of the reason for that. And then I need minus. Anyway, I'll stop here because it, once again, it gets you guys the idea. X minus 1 to the 4th. So if we were to graph this and if we were to change our window, ooh, not to be that. That's a bad idea. Oop, that's not good. Oop, that's a little bit better. Oop, that's even better. Oop, that's even better. If we were to keep going and going and going, when is this going to be looking good? And where is it going to be converging? Not like estimating, but guys, converging, like getting closer and closer to covering an entire interval of a curve. A tangent line, remember, only hits one place. But all of a sudden, all these other ones are hitting, like actually converging to the curve longer and longer and longer and longer and longer, eventually perfectly mimicking the curve from 0 to 2, as you keep on adding in more and more and more polynomials. But we have this idea of derivatives and integrals, so let's go ahead and check out what on earth is going on down here in number 10. We could keep playing and we could keep rearranging. We'll see how you guys do on that part of homework. I don't even think they get that hard in your homework. But what's going on down here in number 10? Oh, bummer. We can integrate or differentiate a power series. This is the end of your endeavor card, to obtain a new series. When you do this, the radius of... some of this you just haven't learned yet. Because depending on the book that you're using, you learn all this at different points. So we'll just leave this for now. Find a power series that represents 1 minus x quantity squared, 1 over 1 minus x quantity squared. And then the hint is, what is the integral? From what we know right now, does this fit the geoseries form? Not the way it is, we have to rewrite it. But what makes this more complicated than the other ones that we've seen at this? It's a quantity squared. Now some of you might be looking, okay. So I could put like a 1 minus here, and then I could put like a negative up there, and then maybe I could do a 1 plus, and we'll figure out the negative later. 1 plus, and then a minus 1, but then it's my common ratio, this whole thing. How do I, there's a hint over here. The hint is here for a reason. If we only know right now how to do a power series, and we'll learn how to do other power series, but if we only know how to do a power series of things that look like this, this is definitely out there. It's a little bit weird, a little bit different. Let's use the hint. What does the hint say to think about? Okay, so integrate that. That's u to the negative 2, right? So integrate that, and what will we end up getting? Just helping some of you guys draw the comparison. So if you use u sub, you get a negative with u to the negative 2. Add 1. That'd be a negative negative, which would be 1 over u. So then we could go ahead and, plus c. Have that be 1 over 1 minus x. How is that a hint? But I need that. If this is the antiderivative of this, how could I get that? Not by plugging in to make it look more, but by instead remembering who this guy is. And then saying, I'm just going to take his derivative. I don't even have to make it look like that. I can just say that he comes from a geoseries, or he comes from what could be represented as a geoseries. And I can just take his derivative and say, so the derivative of is equal to, bring down the negative 1, it'll be to the negative 2 power times u prime. Oops. The derivative of this is that. So what can I do to form its power series? Not antiderive. I know it's weird because you took the integral to be like, wait a minute, you come out of this? Oh, so you're his derivative. Got it. You're his derivative. Derive it term by term. What's the derivative of 1? What's the derivative of x? What's the derivative of x squared? What's the derivative of... So it's going to be, ready? n minus 1 times x to the n minus 2. So So how do you make a power series? Everything is coming back to this, but what's going to be a little wonky when it starts talking about derivatives and integrals is that we can actually, from these guys, not just like plug in and do compositions, we can also figure out power series of their derivatives or their integrals by deriving or integrating term by term as well. So we aren't just able to make power series that look like this or that we can make to look like this. We can also start working with maybe functions of a little bit different form as well. Not just going to like 1 over u squared, but also going to ln. Oh my goodness, a power series representation of ln. Do we all know how to plug into ln? Not so good. Could we plug into a polynomial? Always, all day long. I wonder if that's what the integral, or what the calculator does when it goes to solve ln values. Does it actually know ln, or does it just use the power series representation of ln? Ln! Why are you talking about ln? Because how would we do ln? 1 over u. So if I wanted to find him, couldn't I start with him? And couldn't I take his antiderivative? But wait, I don't want the antiderivative. I want the antiderivative. It would be a negative, so we're going to have to be a little careful on this because I want this guy specifically. But yeah, we want the antiderivative. I would be integrating to get, do we just do this? Yeah, negative ln of 1 minus x. There's that plus c idea. We'll talk about him maybe a little bit tomorrow if you guys get a little confused by him. But coming back, how would I do it? Integrate term by term. Integral of 1 and x is... Wait, but we want this guy. You gotta see why the negative's a big deal. But couldn't we just say, like, we'll multiply him by a negative to multiply him by a negative to multiply all these guys by a negative? We now know what ln is a polynomial. Bye, guys. Can you rewrite sine as a polynomial and cosine as a polynomial and tangent as a polynomial? Does our calculator only know how to do polynomials? And it just cheats?